Oh, this is exciting. We're flying across the country to do some volumetric capture shoots over in Los Angeles.
Yeah, and Eric, this plane is equipped with Wi-Fi.
Well, we brought our Nintendo Switches, so now we can play Mario Kart against each other during the plane ride.
Oh, I need to download it. I didn't bring the actual game with me.
Just go ahead and connect to the Wi-Fi and install it. I'm actually sitting in the row right behind you, so I'll be right here.
Eric, it says it's going to take the entire flight to download. I'm going to call the staff over. Hold on. Can you restart the router? The internet's a little slow, please. I need to download the game so I can play with my friend here. He's in the row behind me. We have 5 hours, and it says it's literally going to take 5 hours, so just restart it, and everything will be great. Thank you. Eric?
Sorry, I had my headphones on. I'm Donkey Kong. Are you ready to go?
Yeah, no, they didn't like the idea that I asked to restart the router. They said the other passengers would be upset.
That's a bummer. I thought you'd be able to stream the game.
Yeah, unfortunately, Mario Kart doesn't do volumetric streaming. You have to download the game, then play it.
Let's start the podcast. Welcome to the Volumetric Roundtable, where we talk about all the latest stuff happening in the world of volumetric. My name is Eric Azares, Head of Product Development at Dengenuity Labs, and we're here today with Denny Breitenfeld, founder of Dengenuity Labs. Hello, Denny.
Hey, Eric. Good to be here.
Today, we're going to talk about the VFA's 1.1 release of the Volumetric Player Specification. Now, this is a major milestone for the industry because this spec shows us how to stream volumetric content from a server all the way over to the end user device. So this is very exciting because it's bigger than just a codec. It's a collection of standards to create a format. So that's what we'll be talking about today.
This is something that the industry has been wanting to do. There's been various different starts and stops, and there's always sort of been a notion of maybe we'll go in one direction, but those directions have always been sort of, as you said in your intro, Eric, just codecs. Like, hey, here's how you compress just data. It doesn't incorporate the whole idea of an end-to-end specification of how does the files get structured on the server, how does the player on the device receive those files, and that's what this release 1.1 really goes into. So it's a big, nice milestone because it is the very first volumetric format specification in the world.
Yeah, and that sounds very exciting, especially with volumetric being a relatively new technology and then really pinning down some of those details that will make this accessible to the masses. And I think it'd be useful to do a quick recap on the various volumetric verticals and how this new specification kind of fits all those pieces together.
Volumetric can mean lots of different things depending on your point of view. Maybe you're in the industry to make some time of flight cameras or structured light cameras. Where does this spec fit? Maybe you're into the whole machine learning and reconstruction world when it comes to Gaussian splats and neural radiance fields. So where does this fit? So going through the verticals can frame how this specification sort of helps part of those verticals and then what's the inputs into it to make this specification part of that ecosystem. So the very first vertical, Eric, is obviously capture. You have to capture all the content. Usually this is in the form of maybe it's just camera related or there's a little bit of processing on the camera, such as, the Azure Connects and Intel RealSense. So that's usually what the industry calls capture and acquisition. Then you have to reconstruct that data. That's a whole different sort of specification and standards. And that's really evolving. We had a wonderful podcast on that. So I'd recommend going to check that out. But once you have that 3D data, how do you actually get it down to a device? And that's what this specification really talks about. It comes out of the working group that is the Decode and Render working group. And this is version 1.1, which is a big sort of cleanup enhancement to 1.0 and makes it more streamlined for companies to be able to implement a way to say, hey, I'm going to get 3D data from a server. I'm going to be able to have the player then receive it and keep track of everything that needs to happen. And it doesn't matter who created that data. It doesn't matter what what the processing reconstruction technique was, whether it's neural radiance fields or splat or meshes. This is a way to have a device sort of receive the data regardless of how it was reconstructed.
All right, cool. So just to recap, so we start with the capture and through the processing, and then we move on to volumetric encoding, then finally a decode and render.
And a lot of times, Eric, people ask sort of, well, can we stream volumetric data already?
I think it's a valid question because when you think about volumetric, getting it from the server to a web browser, how does that work exactly?
The VFA members looked into what is the difference between, say, a 3D asset, or say maybe a chair that you can put in your living room in AR to see if it's going to work, or a character in a 3D game like Fortnite. What is the difference between that kind of 3D assets and volumetric data? And the biggest difference is that you have a static object is like that chair. It doesn't move. And even in, say, a game like Fortnite, where you have your various characters and players and those are moving, what you're doing is you're puppeteering those 3D assets instead of actually sending down frame by frame of the changes in the 3D asset. So a great example is, imagine a clay model, and Eric, I give you my clay model, it's on your device, and I have the exact same replica of it. And I say, Eric, I'm going to move the hand up. And then you are going to actually replicate moving the hand up because you have that 3D clay model on your device. And all we're doing is telling each other sort of the position of where the hand goes. That's what 3D data traditionally is. With volumetric, you don't have that notion of puppeteering. So I move the hand up. I now have to replicate that 3D data, send it over to you, and I have to do that frame by frame. So if we're watching video games or a lot of 3D content in XR and on game consoles and even on phones, the frame rate we're trying to achieve is at least 60 frames per second. So you can imagine sending down the entire model every single frame is a lot of data. And so what the VFA has done is brought in techniques and IP of ways to compress volumetric data that is a lot different than just compressing, say, a static object and then manipulating that object using basic data. One of the key things is that you have to have all the 3D data preloaded. So Nintendo released a new Zelda game, and that is over 30 gigabytes of 3D data that has to be downloaded to the Nintendo Switch before you can start using it. With streaming volumetric data, you don't have to download that 3D data. You literally are streaming it. So it basically is the notion that we go from, say, we have to download a movie and then we can play it back, versus we can just stream it and we never actually store the movie on our device because it's just streaming. That's sort of the analogy. And then the details in it is 2D data. Let's say it's 4K content you're watching on your big screen and you're streaming Sunday's football game. It's probably going to be about 15 gigabits per second to get the highest quality you can, using H.265 as the codec. For volumetric video, streaming, say, that same football game is going to be in the range of about 80 megabits to 120 megabits. And that's with the compression. Without the compression, we're getting into over a gigabit per second of data to be able to stream that football game. So the VFA really worked very hard to sort of solve this idea that we can stream, say, one person in a hologram sort of conference environment where we're collaborating in a virtual environment, all the way to being able to stream a basketball game with all the players on the court and even maybe some folks on the sideline. That's what this specification is really trying to do.
So, Danny, what is the challenge of volumetric data, getting it from the network to the device? It's
a lot of bandwidth. And so we needed a whole new set of compression standards for that. But that's just on, say, the codec side. What you really want to do in a format is make sure that no matter what the content is, no matter what the cloud server architecture is, and no matter what the device is, everybody is implementing the sort of same protocols so that the consumer could switch from one content provider to another. Maybe they stay on the same device and it just works. The reliability, the quality is there. Or maybe they go, hey, I'm going to watch something on my tablet. I really like it, but I want something that has a little bit more control over my movement in, say, the 3D environment, say a basketball game. So they put the content right up on their big screen. It's connected to, say, their PlayStation 5, and they pick up a game controller. Now they can move a little bit more fluid, a little easier because of the controls, or maybe they're more familiar with. And finally, they're like, you know what? I really need to be at center court right now, or I need to be right under the net because the dunk is about to happen. And they can pick up their headset, and all those switches and all those changes, the format will go into making sure that the consumer doesn't realize that there's anything happening differently because the spec isn't letting anything happen differently. And they just get a seamless, nice flow of content from device to device. So that's really a big part of what this player format specification goes into, is assuring that each device knows how to connect to the right server, grab the right files for that moment in time, for that 3D space, and then how to render it back. So that's the biggest part of the spec that the VFA has solved, is compression and reliability and playback across devices, across cloud architectures, so that the end of the day, the consumer has a reliable experience.
There are some existing compression techniques. So how does the VFA specification handle this differently?
And I think a lot of those techniques are valid for some use cases, especially the ones where, hey, we need to get something out the door. Maybe it's marketing, brand activation, and you have somebody that, say, already knows Draco, which is one of those existing standards out there. That's more of like a codec, and usually, you're focused on just the end result, maybe a little bit on the platform side. And maybe you're in an environment where you're in you have the ability to control every aspect of that ecosystem. So you know that you're going to work with this kind of capture technology. The processing is going to be this way. We're going to build a server environment this way, and then we're going to play back another way. That's having the ability to have control over everything. The difference here is that platform that maybe has a 3D content, that 3D content can come from a company that's doing time of flight, another company that's doing Nerf, another one that's sort of invented something completely brand new, maybe somebody that's really focused on voxels. And now it's saying, hey, I want to just not focus on how to do the server architecture, how to do the codec compression. I just want to sort of say, hey, I want to publish to an environment or a platform that uses an industry standard. So you can think of it like, hey, the world of streaming does have a couple of standards when it comes to streaming. I can shoot my content on any camera. I can edit with any editing tool. And when I go to publish to, say, a streaming platform, it's just going to work. And those streaming platforms, over a course of almost 15 years, have naturally fallen into a set of standards. And what this specification is saying, well, hey, here's your set of standards. It's not just about a codec and not about just one or two of these pipelines that work with that codec. It's about enabling the entire ecosystem, regardless of just, hey, this codec is really for those who are working on compression. The player format specification is anybody that's going to be part of that ecosystem. So that's really the biggest difference, is that it's, we're about expanding those who are working in the industry and ensuring that no matter what kind of content you're creating, it just works on as many platforms that adopt the specification. And also, it doesn't matter how you captured it. low-level details is that this specification is really about building out the best kind of experience for all sorts of volumetric content. So whether you're sending down one person in a conference type environment, and then you're bringing that into another environment where, 3 or 4 of us are collaborating, or you're trying to send down a basketball game, the specification allows for the implementation sort of just switch codec technologies depending on what the viewer or the end user is doing. Maybe sometimes the end user is watching from afar, and you can, at that moment in time, the specification could say, use this codec technology. You're going to get better quality, better bandwidth performance, and bandwidth is money. And as maybe you get closer, you may want to be able to switch to a different codec. This is described of how to do that in the specification so that you always are able to present the highest quality content from one person, like I said, all the way up to a basketball team, or in the future, we can be streaming an entire sort of city block with all kinds of people on it. That's what this does differently.
That is leaps and bounds from where we were yesterday. Where is this specification going next?
Yeah, so with the release of 1.1, we really did focus on the idea of 3D compression using codecs. The next one is sort of 2.0, which is roughly, 6 months out from now, maybe less. Excuse me. Yeah, Eric. So in the last 18 months, the VFA has worked on specification 1.0 and then 1.1. And in the next 6 months or less, the VFA is going to release 2.0. And what that does is it allows for another type of way to send 3D data from a server all the way to a device and really give the implementer the ability to pick and choose which kind of, let me start over. It really allows the implementer to say, hey, in this scenario, where bandwidth may be a little bit, hard to come by, they're going to use the new implementation in the up and coming 2.0 specification that is a little bit more bandwidth friendly. Maybe as the 5G networks get built out, and broadband is integrated into more 5G broadband is integrated into more and more devices. Maybe the implementer can choose one of the other codecs, and really 2.0 is saying to the industry, our focus is on developing that format, giving the implementers choices, and making sure that the consumer always has a reliable experience. And so when we think about the release of 2.0, it's really sort of now we have the foundation of compression with multiple different codecs. And what we do from there is add things like end user interactivity standards. We really enhance the notion of different ways to do volumetric audio. And there's several other things the VFA has talked about of where it wants to go with this. But I think, as we said in the beginning, the key thing to keep in mind is that this is a living, breathing specification that all the members of the VFA want to ensure that the specification keeps up with the latest and greatest. It isn't sort of something that you write once, put on the shelf, maybe you implement a headset around it, and then you never look at the specification again. It will continue to grow because all the members of the VFA do believe that this is the next medium, looking forward to the future and bringing the spec up to speed as the technology changes.
Who is this specification for?
Yeah, Eric, really the specification is for the existing members, but as we build out a reference implementation here in the next couple of months, The specification will be for companies that are building immersive experiences inside their existing software applications. So OTT platforms that are thinking about doing immersive experiences, say for sports or movies or documentaries or even, social media. And then also it'll be for chip manufacturers that see a way to sort of incorporate some of this specification into the actual hardware to make the cost of the device, such as an XR headset, cheaper to the consumer, perform a little bit better, and then anything the experience side of the application that can run on the software side of the device, and then the decode and the rendering all happens on a chip. So it's going to be sort of in those waves where it's going to be software based first, then chip based, and that means hardware for, say, smart TVs, the next generation consoles, the next streaming platforms for video games as well. That's who this specification is for.
This volumetric player specification is a game changer, and it's going to be a great way to deliver volumetric video content to users like me and you.
Well, Eric, that reminds me, I have a trivia question related to streaming players. So Netflix has been a pioneer in streaming. I think we all know that. They got into streaming by building a PC application so you can stream on a PC, but they really wanted to go into the living room, which makes sense. That's how everybody watched movies and TV shows over 13 years ago. They had to sort of figure it out on their own. And my trivia question is, when they were trying to figure this out, they had already released the Roku box itself as their foray into it, but they realized that the game consoles of the world were connected and to the internet and connected to TVs. So how did Netflix get into the Wii game console, which at the time was a worldwide phenomenon, and it had the right demographics for those who wanted to watch content on it? What did Netflix do to be able to bring movies to that device?
I feel like it was the mid 2000s. I remember people always inviting me over to play Wii bowling or play Wii sports. So I'm trying to get back into that mind frame here. Okay, so I'm thinking back, Nintendo Wii, and I feel like on the menu screen, there were probably other apps like maybe internet connection apps, and Netflix was one of the options in that menu screen. I'm thinking of like the little thumbnails you would kind of click through, right? And there'd be a Netflix app on the Wii. Am I remembering that correctly?
Yes.
Okay.
You are.
So the question is, how did they get their Netflix streaming onto the Wii device?
That's correct.
Okay.
For the very first time.
Okay. Well, first off, the device has to be connected to the internet.
Yeah.
Right. So that's step one. That's step one.
Step one. Yeah.
And then having software live on the console itself. They would have had to install the software via some type of software update. You download it and then install.
You're on the right track, but one of the things we just now take for granted is that last thing you said is there was a way to do a software update. This doesn't fit sort of a video game, right? So this was definitely different than maybe the Wii Store, which did exist at the time, but it just didn't fit into that model. So what did they do?
Right. Oh, gosh. Okay. No, you're right. Because over 13 years ago, 13 years plus, if I wanted to install something, I would have a physical disc and I would insert it into the front of the console, right? And then it would load and then either run off the disk or it would install software locally on the hard drive of the console itself. Was it like an AOL disk where you have to install like a Netflix application into the Wii?
Ding, 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 ding. We have a winner.
Oh, wow.
We have a winner. It was called the Netflix Instant Streaming Disc for Wii. And I believe I have also a PS3 disc as well. I'm holding in my hand the Wii version. And basically, it was a way for them to bring their app onto the Wii. But it also ushered in this era where they sort of had to build these one-offs to get the momentum of people watching content in their living room on their TV. So they conformed to whatever at the time Nintendo Wii video codec and copyright protection was. And then they do the same for the Xbox, and they do the same for the Xbox 360, the PlayStation 3. And then if a Blu-ray player had an app store, they would build one for that. And they were really doing all the work. And this is a company that definitely believes in standards. They've really helped usher in amazing JavaScript standards, amazing HTML standards. They've helped drive quality standards when it comes to video compression. And if there was a streaming format association set up at the time when Netflix was doing all this heavy lifting by themselves, I imagine Netflix would have really been the pioneer, because over time, implementing all the different versions from the Wii version to the Blu-ray LG version, the Sony Blu-ray version, to finally the iPhone had it, it just became a logistical nightmare because you have all these different code bases. And that's why today they were pioneers in, one, doing a seamless UI across all devices. And then what is that platform? They chose JavaScript. And so I think that they would have been pioneers as well to drive a streaming format. But unfortunately, they didn't switch to a whole standard UI until the early mid 2000s. And it basically took several years before some kind of consolidation was happening around streaming codecs and backends. And it's still in some ways the wild, wild west. But 13 years later, it's gotten to the point where the VFA wants to be right off the bat. So we're really at the forefront here, learning from the idea that, yes, you can, going back to the Wii and Zelda, you can, go alone, but it's probably not the best idea to go at it alone.
This episode of Volumetric Roundtable is produced by Dengenuity Labs, brought to you by the Volumetric Format Association. The VFA is a global professional community, and we work together to drive our technology forward through best practices, standards, and collaboration. If you'd like to join the VFA, go to volumetricformat.org/join to learn more about our membership options. We even have a community membership option, and it's free to join. My name is Eric Azares. This has been the Volumetric Roundtable. Thanks for listening, and we'll see you in the next Mixed Reality.